Hello guys. Hi. Welcome to our channel. Welcome to the One Source PH. Today in this video we are gonna solve some problems about conservation of energy. So this is the problem that I asked my students to solve for them to be able to pass the fourth quarter. Okay. So they're allowed to submit their solutions in a document format, PDF format, or image. So this is just worth 10 points, and the problem goes like this. So the time it takes for the object to fall is 2.5 seconds. All right. So the mass of the object is 1 kilogram. Then A, calculate the height of the object from the ground. Second, calculate the velocity. All right. Um, when 99.99% of its total kinetic energy or total energy is all kinetic energy. So what is the total potential energy of the system? So there are three questions here, and there are two type the answers right here and upload the solution. All right. So I actually prepared a PowerPoint presentation for that, which is this one. So conservation of energy, and we're going to discuss it one by one. So here is the problem, and I also gave a clue. All right. So because this can be solved by using the principles of conservation of energy or by using the concept of free-fall motion. So I try to merge the two, okay? So to be more creative, so let's do part A, calculate the height of the object from the ground. So basically it's the distance from the ground, so we are looking for D. And here, part B, calculate the velocity when 99.99% of its total energy is all kinetic energy. So, and then what is the total potential energy of the system? So you can start from the clue right away because that's obvious. You need to find D, and you have time, which is 2.5 seconds. So I think you'll not have a problem in finding D. So in doing that, you're gonna derive a formula for D, and that's gonna be 1/2 GT squared. All right. So here is the computation. So that's 30.625 meters. And I asked them to um, write it in two decimal places only. So this will become 30.63 meters. So if you do not have the unit, then you're wrong. Okay? So because what is 30.625? I do not know what's that. Okay. Yes, in physics, you should know what you're trying to measure, what you're trying to solve for. So right now, we're gonna go with my paint, and we'll do the derivation there of the formula and the solution. So we have part A, okay, and we have part B, okay. So part A is simple, I think. All right, so you'll start with t is equivalent to square root of 2d all over g. So you cross multiply. Well, the first step is to remove the radical. So raise both sides to the power of 2. All right, so that will cancel out. And then you're going to have t squared is equivalent to 2d all over g. And then cross multiply. All right, and then this one. So you're gonna have t squared all over 2g is equivalent to d. And you can plug in the values. D is equivalent to 1/2 times the value of g. Yep, is equivalent to 1/2 times 9.8 meter per second squared times 2.5 squared. All right. So that's 30.625 meters. All right. So 30.63 meters, two decimal places. Okay. All right. So that's one solution, and we're gonna go with the next one. All right. So we're not gonna save this, but technically I should be seeing something like this in your solution or in your, yeah, in the document that you're gonna upload. If I cannot see that, well, you still have a point. Well, 3 points. All right. So if you pass a blank one, you're gonna get 1 point. All right. Part B. So that's calculate for the velocity. All right. Velocity when 99.99% of its energy is all kinetic. All right. So meaning to say our object now is falling. All right. So I think, yep. Okay. I cannot throw a building. Uh-huh. So I just need this thing. Yes. Why not? And there's a box on top or something like an object like here. All right. And that object will fall. All right. Down there. And right here, it has its velocity, and it has its kinetic energy, kinetic, and that's equivalent to 1/2 mv squared. But the amount of the energy that can be converted is based from the conservation of energy. Total energy is equivalent to PE, which is the potential energy, plus the kinetic energy. So on top, it's all potential. All right. So kinetic energy is 0. So on top, this is equal to TE is equivalent to mgh. All right, plus 1/2 the mass times 0 meters per second because it's not moving. All right, raised to the power of 2. Okay, so on top, this is just mg h. All right, so we have a formula for the height, which is equivalent to the distance from the ground. So we can rewrite te as m times g times the value of h, which is 1/2 g t squared. All right, so we can simplify this as te is equivalent to mass times g times g, so that's g squared, t squared all over 2. So this is the value of the total energy that can be, this is also the value of the total energy that can be converted into kinetic energy. So we're gonna equate the two, all right? And we know that 99%, okay, so is converted into KE. All right, so don't save, and we have here a new formula. So we have the formula of 0.99 of the TE is converted into kinetical energy or kinetic energy. So that's equivalent to 1/2 mv squared. All right, so that's 0.9999 times the formula that we have for TE, which is mass times g squared, or acceleration due to gravity raised to the power of 2 all over times t squared all over 2 is equivalent to 1/2 mv squared. So the trick is to cross multiply to remove this and remove this. Okay, so yep. So or we have a factor. Yeah. Okay, so we can just write a factor 2 over m, okay, times 0.99999 times m t squared all over 2. All right. So that's if whatever you multiply to the left, multiply to the right, times 1/2 mv squared. Alright, so you will see that this one will cancel out, right? And we will be able to isolate this, and same is true with this. Alright, so you have a formula now which is 0.999 g squared t squared is equivalent to v squared. Well, that's new. Okay, if you have learned something, please click the subscribe button, hit the bell icon, and give us a like. Alright. So for you to be able to learn a lot of things from the university, from the One Source PH pala. Okay, One Source PH is our new channel, guys. Okay, so we're gonna solve for this. So we're gonna take the square root of both sides. So we'll write b squared. Alright, so take the square root of that is equivalent to the square root of 0.99999 and so on and so forth times g squared t squared. Alright, so if you take the square root of that, it will be just 0.99. So I think we'll just write 0.99. You can actually try. So to make it exact. Alright. So we'll write v, or the velocity now, is just equal to v is equal to 0.9999 g t. Alright. This is equivalent to 0.9999 times 9.8 meter per second squared, alright, times 2.5 seconds. Alright, so cancel this one, and the unit will be units of velocity. So if you're gonna compute this is around 24.49 meters per second. Alright, so I should be seeing things like this in your final answer. Alright, so yes, and the total energy is 300.15, alright, or 300.13 actually. Okay, so how is that done? Okay, so this is part C. So I hope you are learning something. Okay, so we have total energy is equivalent to mgh, and that is equivalent to T mg times the value of h, or the value of distance, is 1/2 gt squared. So we're gonna have m g squared t squared all over 2, and this is just equal to the mass of the object, which is 1 kilogram, times 9.8 meter per second squared. Yep, raise that to the power of 2, alright, times 2.5 s to the power of 2, okay, all over 2. So this is just equivalent to, alright, well, let's check the calculator. So I think we can do this using a simple calculator. Alright, so that's 9.8 times 9.8. So you're gonna have meter squared, second squared, okay, or second to the fourth power. Alright, so that's 96.04 times 2.5 times 2.5. Alright, numerator, denominator. So we'll stay with meter per second squared. Meter squared second squared. All right, times kilograms. All right, that's 600.25 divided by 2. So you have 300.13 joules. Actually, that's all right. Or yes. So we include the unit J. So I should be seeing this, guys. If I didn't, then you're wrong. Okay. But if you tried, maybe you'll get the minimum of 3 points for the effort. And thank you so much for the answers, guys. Good luck in your examination.